Hello everybody, this is Mr. Bowman. So today we're going to be looking at graphing two-dimensional inequalities, and since this is a graphing one, I want to make sure we use the tools that are in ALEX to make sure we see how these work and which ones we need, which ones we don't, that kind of stuff. So we're going to do this one directly in ALEX. We're going to look at two questions, one that is in slope-intercept form, which is this one, and then we're going to look at one that's in standard form as well to see how we want to approach that. All right, so if it's in slope-intercept form, I'm going to pretend it's a regular equation for a moment. So I'm going to graph it, ignoring the inequality, pretending that's an equal sign. So I'm going to come over to my line tool, and specifically a pencil, so I can see what I'm doing. And this is my y-intercept. So I'm going to go to that number on the y-axis. So mark 1 there, positive 1. And then I have a slope of -3. Remember, if it's a whole number, that's over 1. So I'm going to go down 3, 1, 2, 3, right 1. Then I can use my line tool to click on those and get my actual line. So the way that inequalities differ from lines is in two aspects. Sometimes they'll be solid and sometimes they'll be dashed, which is what this tool is for. You can click on this to make it a dashed line or a solid line. Okay, and there's going to be shading, so you might shade one of these sides or not. So it may be shaded on this side or maybe shaded on the other side. So it's going to be one or the other though. So to figure out which one of those two things, we're going to start with the solid or dashed part. So to know which one's which, I'm going to look at my inequality sign right here. If it's or equal to, so it's less than or equal to or greater than or equal to, it's going to stay a solid line like normal because it has an equal sign in there. So it's going to stay like this. If it's not, if it's strictly less than or strictly greater than, then you're going to change this to a dashed line. Okay. So in this case, it's less than or equal to, so it will be solid. And I don't have to do anything else with that. So now I need to figure out which side to shade. So to do that, I'm actually going to pick a test point. So I'm going to mark it so I don't forget which one I used. So I think I'm going to go with 2, 2. So which is on, if you'll notice, the right side of my line. So we're kind of split into a right and a left part here. So it's on the right side, and that's important. So then I'm going to plug in my coordinates. So in this case, 2, 2 has a 2 for x and a 2 for y. So when I plug that in, and you can do this by hand, but you should end up with 2 is less than or equal to -5, okay, after you clean that up. So the question is that true or false? So is 2 less than or equal to -5? That is false, right? So 2 is definitely bigger than -5, not less than. If that's true, then I would click on the side with my test point. If it's false, I'm going to click on the other one. So in this case, it's false, so I'm going to click over here, and my shading will be on the opposite side as my test point. Okay. So that's a slope-intercept one. So I'm actually going to change my mind a little bit. I think we're going to do one more with slope-intercept form before we jump to standard form, just to see it all kind of in one go. So looking here, I start at 3 on my y-axis, because that's my y-intercept. And I have a slope of -1, so down 1, right 1. Line tool, click on those 2 points. Look at the symbol. This is less than or equal to, so it stays solid because it's or equal to. Then I pick a test point. Let's go with 0, 0. Origin's always a nice one. If I plug that in, I get 0 is less than or equal to 3, which is true, so I'm going to shade the side with my test point. So that would be shaded down here. All right, so the only thing that changes for the last couple questions is instead of slope-intercept form, it's in standard form. So how that changes is you will want to solve it and put it in slope-intercept form before you start. So this is entirely done off of ALEX, but you just want to solve for y. So in this case, you'll subtract x and then divide by 4. When you do that, you'll be back in the situations we were in over here, where it's in slope-intercept form, and you do it just like you did the other question. So there's just one step to do before you start.